I'm Gil.
I'm Arda.
Both open source developers at the Guild. And we're here today to talk about a federated gateway for an API protocol, for any API protocol. It's kind of a big thing to say, but we will break it apart soon. I will say a couple of things before we begin. First of all, we planned it as a hands-on workshop, and we'll try to do it. I'm not sure if the Wi-Fi will manage it, but it seems to be fine for Yarn install, and that's basically what we need. So we'll try. If we see that it just doesn't work out, we'll switch to demonstrate only. Another couple of things not related directly to this workshop. There is a meetup afternoon. You maybe have heard of it at 5 p.m. right here on top of our heads in the main floor. So please join. It's free and it will be interesting. There are a few talks I'm planning to attend, so I hope to see you there. And the second thing, if you take photos, share or tweet or X, I don't know, your ideas, your thoughts about the talks, please use the GraphQL Conf hashtag so you'll be able to all see it and share it and track and respond and so on. Shall we start? All right.
Let's start.
So, what's the problem and what we are trying to address in the solution that we'll suggest here? Those problems, is it big enough? I'm not sure. The people in the back can read it? Yeah, good. We're trying to address some problems that you might be familiar with. They can occur on multiple cases. We'll address it at the end. But the first problem that we will touch today is that on our projects, we sometimes use multiple data sources of multiple types, either SQL databases, MongoDB, Neo4j, GraphQL, obviously, SOAP, OpenAI, JSON schemas, and so on and so on and so on. And we need to be multi-talents in many different specs, which is hard time to maintain. Second problem is that we want to combine them all to one coherent API that we can consume, that our clients can consume. Another problem is that it's sometimes needed to adjust, to transform some things in those sources. The names doesn't make sense to the people who will use it later and so on. And obviously, sometimes we want to wrap those and add some layers of caching, of rate limiting, of security, and so on. And we'll show our solution to all of those problems today in the tool that we created. It's called GraphQL Mesh. Who of the participants here heard anything about GraphQL Mesh? Good. So half and half. Great. Yeah, great. Some of you have no prior thoughts about it, and some of you have. We will try to participate, to go through it today. Some of it, of the features that we have in Mesh. And I will say that there are two different resources that you should know, and you can already open them on your MacBooks or whatever laptop you're using. The first of all is the Mesh website. It's got documentation. Basically, I believe the documentation is not that bad, and you don't need us. I mean, you can go there and do it by yourself. We're here to guide you and to help you with it, but it's the first source. I'll show you it in a bit. The second source is the repository created, dedicated for this specific workshop. You can see the link there and go and see through it the steps that we'll do today on the workshop. And obviously for future references. I will just show that I'm the GraphQL Mesh website. In it, we will use those docs. You can already try to scroll through it and see what catches your eye. But in the docs, there is a getting started guide, which we will use parts of it just in a couple of minutes. You can already try to go through it, but before you do, let's start with one basic task, one basic feature that Mesh has and can help us with, and this is creating a basic gateway. What Mesh technically do is takes lots of kinds of data sources and convert it into GraphQL. That's the basic first capability that Mesh does. So we will soon install the dependencies, create the basic configuration file, and for the scope of this workshop, we chose a real public API to work with, GODB, which provides data about cities and its population, rather basic. That's the link for its docs. Just to digest it a little bit, there are two links, one for the Swagger schema. This source specifically is got a spec, Swagger spec, and the endpoint from which you can retrieve the data to send requests and get some data back. Let's try to see if it works. Just create a new package in your, on your computer, install the documentation is there. Install Mesh and create the basic specification for it using this endpoint. I'm not sure if it works. Let's try.
Hopefully it works.
Yeah. If not, we'll demonstrate it here anyway, but let me know if yarn install works for you.
Yeah, let's try.
If none of you connected to the Wi-Fi yet, you have this password here on your card, so everyone can use the GraphQL on Wi-Fi.
Okay, we need to GraphQL Mesh CLI, GraphQL Mesh OpenAPI,
And GraphQL. Yeah.
and GraphQL. Let's see if it works.
Yeah. Meanwhile, for the less brave ones of you that are just here to watch, Arda is just installing 3 dependencies. GraphQL is the first one, GraphQL CLI, which is the core dependency, as the second one, and GraphQL OpenAPI is the third one. Because we are using OpenAPI source, Mesh is structured in a modular way, which means each part is it's got its own package and need to be installed if you use it. If you don't use it, you don't need it in the bundle.
Somehow it doesn't work.
What?
It's the connection, I guess. Yeah, install doesn't work. It takes forever. So luckily we already. I'll just use the branch.
All right.
So we need these 3 packages. Like in Mesh, we are installing packages based on our needs. In this case, we need CLI, of course. Then we need OpenAPI handler. Then GraphQL package, just like other GraphQL tools in the ecosystem. And we'll create a basic Mesh configuration file. And let's call it GODB. And let's define the handler. In here,
second, just for an overview, even us locally cannot do yarn install. So unfortunately, we'll do it by demonstration. If you do get decent Wi-Fi from your own package or whatever, you can try it by yourself. I encourage you to do it because you'll have better and real question about it, but we'll demonstrate it anyway for the benefit of us all. The Mesh configuration file is a YAML file. It looks for a .meshrc.yaml file in the root folder. That's what Mesh is aimed to do by default. You can specify if you need, for some reason, you can specify another path, but basically that's like the most basic setup. In those files, you add a source property, which will include eventually all the sources, the data sources that you are trying to mesh. For now, the first one, we name it GODB because it's the source for the ease of use of internally, and the kind of data source, the handler, which is OpenAPI, because this source is OpenAPI. We'll later on add another one from different kind of source, but the first one is OpenAPI one.
Okay, so the input sources, the Swagger file. So we give the URL here, and we define the endpoint for it. And we can just go.
Yeah, I will say, Ed, if you scroll to the documentation in the website, you'll see there are lots of more configurable options. But for the most basic setup, if you got a decent OpenAPI spec, you can just define the source, which is where the schema is, and the endpoint to which you want to do the request, and that's it. The most basic configuration, just like that. Mesh can digest it and create a GraphQL schema out of it.
Yeah.
Will you show us?
So we have dev commands in GraphQL Mesh. So it basically runs a development server, GraphQL server in development mode. Let's see. It works. Okay, good.
Good. So Mesh opens up graphical basic explorer to the schema. You can see lots of endpoints, lots of fields being added to the query because it took whatever was in the spec. It uses the whatever data it can get, descriptions and variables and so on. It used a basic naming convention, which is on this case based on the operation tag of the OpenAPI spec. If not, it uses kind of the path of the internal spec. But for now, you can see that we've got a few.
Yeah, we got a few here, but we will use findsties. Yeah, this is the basic one. So in findsties, we have location. So yeah, based on the description, it accepts latitude and longitude in this format. We can basically choose, we can just take some coordinates in London and copy it from Google Maps and paste it. Let me check the formats to make sure.
Yeah, the plus to begin with.
Plus?
No.
No. Oh,
yeah.
this one. Okay. Let's see if it works. What did I forget? Okay. So you can.
Yeah. So what Arda just did is he took the location of London, but you can try it for yourself with any city that you feel like for. Took the longitude and latitude and feed it into this variable because that's what the source that we're using is accepting. I will say that because the generated schema is based on the original spec, and in the original spec, errors are defined well, you can see that the response type is actually a union of 3 different types because errors are also already typed for us. It's good for production, for real use cases. For now, for our usage, we'll only use the good response, here, the populated city.
You can just use autocomplete. Name.
Oh, yeah. Good enough? Name and population, that's like the basic fields. And if we did everything right and Mesh baked it well, we can now get real data back. So, yeah, just by that, thank you. That's only the basic magic. We'll soon level it up. But we took an OpenAPI spec, and by a few lines of codes and 3 dependencies, we converted it to a working GraphQL schema, which is already good for us, the ones who understand the GraphQL and don't all the time have better similar experience with the other types of data sources.
And we should keep this on night because we will use it later.
Yeah.
So this type represents the city.
Yeah, this type represents the city. We will soon, I'm letting you know what
Yeah,
happened in
we'll
2 steps
extend.
ahead. We will add some fields from another type of data source into it. We'll stitch it together. So we'll just keep in mind this populated city type. We'll be back to it in a minute. So we've got a schema. Maybe before we continue with this, I'll just show you that Mesh generates an artifact called in the .mesh folder. In it, you can see the GraphQL schema that it created. It has some directives for expressing the data it got from the spec. But for each endpoint, for each specific endpoint, it created the type and the path, but in GraphQL spec. If you did it locally, you can go through it. It's a rather big file because it's a rather big data source to begin with. But this file will change in a minute because the next thing we want to do, I don't know if you noticed, but because we are using the operation tag as a baseline for naming, all of the fields on query got this weird suffix, this using get suffix, all of them. That's how it is on the original source. I don't think it's so useful to us. It doesn't look so nice if you want to use it internally. So next step, let's get rid of it. I mean, we can easily do it with Mesh. It's got multiple transforms, but let's use a rather basic one, the rename transform. Once again, because it's modular, you need to install this specific transform that you're using, the rename transform. We'll demonstrate in a minute, and add the simple configuration that it needs on top of the configuration we already have.
Okay, let's continue. Yes. So let's, you can also check the documentation in the website. Like Gil said, it is the best source we have. It is not perfect, but currently, I think it's not that bad. Okay. Okay, sure. Okay. Yeah, thank you. So we'll use rename transform. Like any other mesh feature, we need to install the relevant package. In this case, we'll use transform rename package. So let's go back to VS Code. And yeah, I'll cheat here. So, okay, here. Good. Should I, or? Come here.
I will say that we try to create a configuration as upfront as possible, but you can see here, we added another property, the transform one, for all of the transforms that we are doing on our schema. This one is called rename, so rename is the next bullet. And what rename does, it takes a type or a field in a type and renames it. It can either rename directly a specific the exact name into another, or as more relevant to our case, it can use regex to find
To find the fields or types.
yeah, and do it like generally to all of the fields in the schema, all of the types in the schema.
Okay,
yeah.
let's do this. Okay, we'll rename the fields in the query type. So we define type query. Then in the fields, we'll use regex. So we'll change everything. Ends with using gets, and yeah.
Replace
use
it with
this,
itself, yeah.
just like in JavaScript or any other languages. And we'll use this flag to let Mesh know about it. Let's run it again. Let's see. Cool. So there's no using get suffix anymore. We can test it again.
Yeah. If you run it as is, it will error because.
Yeah. So yeah, using get shouldn't work. It's warms out already. Yeah, it fails. Okay. Cool. So
second step up, we've got now a more coherent, more readable schema out of the data source. And we're now going to get to the third part, which is where the real magic happens. We're going to add another data source. This one is not OpenAPI, another one. We'll add some complexity to it, just to see that we managed to work it out. The second source that you added, every decent city that that is proud of itself must have, obviously, some breweries, especially if the population is high. So the second source is a brewery source. Let's just show you the website of it.
Yeah.
Because what's interesting in this data source, that it's got a well-documented website, as you can see here, but it's got no spec at all. Literally nothing. It's basic raw documentation. It's something that we face sometimes. We have an endpoint. It doesn't have any spec to it, and we do want to use it in our mesh. So in this case, one of the benefits of this source is that it's got good examples of responses, which is the most important thing for us. So let's just take this response that we get in here and the endpoint that is shown right above, and let's feed it to mesh as is. No spec, but add a source based on samples that we get from the request we did in the past.
So let's check again.
3A.
3A.
Yeah.
How do we do? Okay. Let's close this one.
Yeah.
Okay, here. Okay.
All right, yeah. For this case, as the baseline, if we get JSON object response object but no schema, we'll use the JSON schema handler, because it's the most the one who matches the most. And specifically, the JSON schema handler knows how to use samples as a baseline, no spec at all.
Can go with documentation.
Yeah.
JSON schema samples. Yeah, you can basically provide.
Yeah. Just to have a quick glance at the documentation, it explains how to use what we were just doing in the exercise. You add another source, obviously. You name it in the name that is relevant to what you're actually using. You specify the handler that you're using and installing it, obviously, because in this case we use a new handler and we need to add a new package to it. And instead of defining the spec, we just add a path to the local JSON file, which is the sample that we took from the request. Yeah. So here you can see we added, because it's one endpoint, it's no good spec, so we need to define endpoint by endpoint. But here we define that in the under type query, we have the breweries field, in which the path that we're using is breweries with a specific query argument, which we called by city. There are more in the website. We can add them all, but for now we'll use this one. It's enough for us. And the path for the response, which we just took from the website and added to our package. That's it for initial adding of the second source. Let's run it. Good. So now we can see we have a new query field that accepts one variable, the by city, and will provide us some breweries of a specific city. But the real magic is not just piling data sources on top of another, but stitching them together.
So let's test it first.
Oh, yeah.
Yeah.
Here, just to test that the data source that we added is working, Arda just shot a request for the London city, which we showed before. We've got multiple breweries in London. If any London citizens here? No? I know there are some around, but yeah. If you don't know them, not familiar with them, you can have a visit. If any one of you is still trying to do it by himself, herself, and get responses, just look for your city and see what's what's there.
Let's go back to
Yeah. So the next part of this exercise is stitching them together. We want that every city that we saw its population in the previous tasks will have another field, breweries field, and so we can have a one object with the population of the city and the breweries that are available on it. I will say that it's rather tricky, maybe the trickiest part we did so far. Let's see if it's understandable and try to show it live, how we do it. Yeah.
Okay. Let's close this again. Yeah. This
All
is
right.
the extension.
So for that, we introduced a new property to our spec, which is extending the types, adding an additional type. We take the type that we've talked about, that we mentioned before, the populated cities type, which is the response of each of the types on the first source, and we add to it a new field called breweries. To this field, we added a directive, a mesh directive, that makes it that enables us to do the internal secondary call to the second data source and then combine them together. You want to explain a little bit about the directive?
So we have a special directive called resolve2. It basically takes 5 arguments. We refer to source name, then the root type, we'll use the field of it, then the field itself, then required selection set. Yeah, this always, I mean, this one is a bit complicated. If you already know the key in federation, this is kind of similar. This is the selection set. I mean, this just defines the fields we needed for our secondary call. Because let's say, let me give an example here. I think we had it here somewhere. Not this one, sorry, I lost it. Let's say we made our call like this. I mean, there's some fields here. And in this case, we don't have a name here. And like after that, if we don't define required selection set, the breweries API won't get that field. So we need to like tell the gateway to add name fields to the result of the GeoDB source. Then we define the args. We had by city arguments, and we'll use the root objects name property here. And then we can just run it to see if it works.
Yeah.
While
it's running in the background, I will say that if it was not clear, you might use from the basic type, from the populated type, you might just not need the name property, like straightforward in the query that you make. But you do need it internally to do the secondary call. That's why you defined it here in the directive, because it must be required internally to do the secondary call. So even if your query or fragment does not include it, internally it's added by this directive.
So let's see. Do we have an example on here? Okay, I can use this. So let's find cities. I want to show. Yeah, here. we have breweries field here, which we added, and it has brewery type. So we can test this. Name. Oops, didn't work somehow. Did we do something wrong? No.
It works? Go to, not all of, apparently, as I said, not every city has a brewery, unfortunately. But if you go to London, for example, not to the suburbs of it, you'll see that it has some. No, it's fine. It was there. Just scroll a little bit.
Oh, okay. Oh, okay.
Yeah, exactly.
I was just. Yeah.
So here we go. Some of the cities doesn't have breweries located in it, but some of it obviously has. And here we get one type, one coherent type that merges those two data sources into GraphQL, which is what we're here for. And here we get one endpoint to rule them all.
Okay, so let's go back to documentation.
Good. So on top of all of that, there are multiple types of data sources that we can use and add to Mesh. There are multiple transforms. We'll show some of them just to name them later. But we said that we can add on top of this proxy, we can add another layer of plugins. And Mesh come with a few. For now, we'll example one of the basic ones, which is response caching. Then again, what we need to do is, you know it already, we need to install the dependency, the relevant module, and add the configuration relevant for it.
Let me show the documentation first. Where was it? The plugins under. This package and configure it like that. Let's do it. Okay.
Yeah. Plugin, as you've understood in the configuration structure, plugin comes in a new property in which you define all of the plugins that you add on top of the proxy. Here we added the response caching and we added the TTL, we added life expectancy to the cache. We set it up for half a minute, 30 seconds, and we can now run it and we can check the log and see if it actually works as expected or not.
Yeah, let's get some ugly logs.
Mesh comes with the debug mode option, which gives you verbose logs of everything that happens under the hood.
So let's see. Let's have a list. Okay, so let's check the logs.
All right. First attempt, first execution of the query.
Yeah, we have HTTP request here with headers and so on. Let's do another. Oh wait, maybe this won't work. Oh, there's some URL errors. Unfortunately. Yeah. Yeah, it doesn't work because there are errors here.
Oh,
Yeah, because of the API.
all right. That's what's happening in real life workshop. We try to use like public APIs, and apparently we've got some API issues. So
Yeah.
yeah,
We can try something because this comes from the brewery API. We can try this one. Yeah. So here in debug mode, it shows if it hits cache or not, and like it shows, yeah, it is cached and the TTL. So here, this query, this operation, didn't hit cache, but it is cached now. And let's check the logs to see Yeah, we have the original response here. Let's do another one. Oops. This doesn't have. Oh, okay. So, yeah, this one hit the cache. And in the next call, yeah, I start to understand here. I'll skip this. Yeah, here it says it hit cache. So this doesn't make an HTTP request, yeah, which is faster, obviously, because the connection is not good. Yeah, this is the response cache, actually. You can also configure it by types. You can define specific details for specific root fields and types. And you can also have caching based on some authorization details, just like user ID, IP, maybe. That's it about response caching. Should we mention about like the other plugins?
In a bit. Let's wrap it up
Okay.
for now. All right.
So,
So obviously this part went faster than expected because it was demonstrated and not like a real exercise. But just to wrap it up, what we did until now in the past half an hour, 40 minutes, we created a mesh gateway out of one OpenAPI source. We transformed this source to be more readable, and then we introduced another data source, JSON schema one, and merge them, stitch them together into one type, one easily consumed type from the client side. Afterwards, we added a plugin to it, in this case, a caching plugin, and we've got a working API with those capabilities included. That's what it did so far. Before we'll go to an overflow and touch some of the stuff that we did not include in this exercise, maybe some of you have some questions. Yeah.
So when you speak to two different data sources, right? How does that respond? Like one of the data sources is slow. So will you wait for the longest
Different
or
stream.
will you respond back?
if you don't use something like different stream,
So, repeat the question. The question was, what happens, we're using two data sources. What happens if one of them is slow? How is it managed?
so there are two ways of handling this. First, you can use defer directive, which allows you, let me show it. We haven't configured it, but I can quickly show how it's done. Yeah, this one. You can basically add defer, not like this, but with some, I will just give a random example. Let's say you can use defer directive here, and in this case, you will get the parent result, the first result. Then after Brewery API response, it will give you another partial result. So you don't have to wait the Brewery API if it's slow. This is the one way of implementing it. Or you can use, you can give a timeout, basically. But in that case, you won't get the results from Brewery. Other than that, unfortunately, you have to wait both APIs to respond. Maybe, yeah, this is actually a common thing, common problem in GraphQL, like which is solved by defer directive. Maybe you can look at it, but Mesh supports it. I don't know. I think this is the only solution we have today.
In a way, it's not different than having a complicated resolver in which some of the fields takes much longer to calculate. So in this case, it's external source, but if you know that you have a source which is limiting your response, you can use this external feature. It's not a mesh feature. It's a feature that mesh support the different stream directives.
But the client should support deferred too.
Yes, yes.
Otherwise, it will
Yes,
interpret.
Second partial result will be ignored.
True.
Yeah, it's an additional feature that the consumer should be able to handle it as well.
Yeah.
How do you get the debug details and extensions for caching information?
I mean, like it's provided by envelope plugin, but is that? What do you mean exactly by? I mean, it's for development for sure. Like it's not something you should rely on production. This is for you to know if the response is cached or not. But it is. I don't know if did I understand correctly the question. Oh, you mean, yeah, it is done by this environment variable. Just
It's
you,
rather small. If you define an environment variable called debug and you set it to 1, it will enrich the logs, the console logs, and the responses with some extra data which is relevant for development. If you remove it, it will not be shown on the responses.
yeah, by the way, like you can see, there are no HTTP requests after it is cached. Like you can see, like parsing requests in here.
Yeah.
So converting from one format to another always, in my opinion, it's tricky. I've had to do it myself. A couple kind of things that come to mind. If you're converting, like let's take the OpenAPI spec. You're doing OpenAPI to GraphQL. Like there's two edge cases that come to my mind. Notably naming differences, just because something valid REST and something valid GraphQL, and then unique types on scalars. It's not in general supported by default. Well, without some hacky workarounds, you don't really have that in GraphQL. How does the mesh handle this?
Did you say scalars?
Yeah, so if I define, say this field can be a string and an integer, I can do that post API spec.
Yeah, Mesh creates scalars. Like let's say you have pattern, which is used by JSON schema, and you can provide regex in there. In that case, Mesh creates a scalar for that regex, and for the other types like datetime, URL, or email address, GraphQL Mesh uses GraphQL scalars. Let me show it.
But so this will generate a weird scalar called, let's just say scalar integer.
Yes, but it also, like, it uses directives in this case to specify, like, I don't have an example in here, but it uses directives to say, like, this scalar uses this regex for validation. And like for the other known types like datetime and so on, it also has this specified by directive that shows the specification for that scalar. And it refers to, for example, for datetime, it refers to ISO specification, RFC specification for that. For email, it refers to W3 and so on. So that's how we handle the scalar here. Yeah, we use GraphQL scalars mostly. It has a bunch of scalars here, which also fits OpenAPI specification and JSON schema specification.
So then just the second part of that question, the naming differences, like what is Mesh going to do, for example, something starts with a number in OpenAPI?
Okay, which is a good question.
Yeah.
People cannot hear.
Question was, how does Mesh manages name differences? I mean, some specs might have a name which starts with a digit, and it's not acceptable on the GraphQL spec.
I remember we documented in here. Yeah, this one, right?
Naming convention.
Yeah, naming convention. Yeah, type naming. This is for just types. But before generating types and fields, Mesh sanitizes it for GraphQL. For example, in GraphQL, like any fields, types, and arguments also, the name of them cannot start with a digit. So in this case, Mesh adds underscore, for example. And if there is some not supported and like unsupported characters, for example, in different alphabets, for example. In this case, Mesh replaces them with their names. In this case, for example, like if it's, I don't know, greater than or smaller than, so on, Mesh just replaces it with their names. And for these ones specifically, for dot, slash, or like underscore, underscore is okay. And for that kind of fields, Mesh just replaces them with underscore.
Yeah, I will say that it is a problem,
It is a problem.
on converting, and we have to make some assumptions and do some magic to make it match, because obviously there are differences. Once in a while, we encounter a new edge case that we didn't address, and it's as an open source project. I don't think if we mentioned it. Mesh is entirely open source. You can see the progress of it. And obviously, once in a while, someone opens a new issue about a new edge case that we should address.
I can even show the source code, like for this like how we sanitize things very quickly. Not
Let's see, meanwhile, if there are any further questions. Yeah.
Is there any maximum response size that you mentioned?
Maximum response
Size.
size. Is there? I don't.
It depends on the environment. Actually, we use the like if the environment has some limitations, Mesh just Mesh doesn't have a specific limitation for that. Mesh just use, like, let's say if you use Cloudflare workers, Mesh just uses its fetch. Then if that fetch has some limits, Mesh has that as well. So other than that, Mesh doesn't have a specific limitation. By the way, like about this sanitizing names, this is the source code, if you're interested in. Yeah, like I just wanted to show it because the entire project is open source.
Yeah.
Even broken ones. Yeah, Mesh also heals, like, let's say if the OpenAPI spec is somehow not valid fully.
Which is
Mesh,
most of the cases.
yeah,
in reality.
and Mesh tries to heal it by using another package, which is called JSON Machete, and like it basically takes the OpenAPI specification and like tries to heal it if, like, by doing some assumptions. Yeah. But if it doesn't, it just throws an error.
All right. I'll give. Another question. Yeah.
Say you have like two APIs, they have the same object, like unpaired, and they have even the same attributes. How do you handle that?
Duplicated names.
Okay, duplicate names, but it can be type merging as well.
Yeah.
So there are the two different solutions for two different cases. So my question is, are they referring to the same entity? I mean, do they share the same ID? I mean, are they the same objects, basically? So, sorry. Let's say they're completely separated. Yeah, in that case, like by default, Mesh just collapses the types. And if you don't want to do it, you can basically use rename transform to handle it. Yeah, this is the only solution we have. Yeah, maybe.
Yeah, let's see if I understood the question correctly. If you've got two data sources with the same type name, that was the first part, and then you can use rename transform and change one of them. Like the suffixes that we just removed, just the same. The second part, if we add a field, just like we saw to this type, will it add it to both of them, right? It depends. I mean, if it's a merged type, it depends on the field that you use in the query. If you're using fields from both of the data sources, it will do behind the scene request to both of the data sources. If all the fields are from one, it will do only the relevant one.
And you can also use, let's say if you don't want to rename the fields or type names one by one, you can just use prefix, just like namespaces. And you can also use encapsulate transform if you don't want to rename types and fields. This transform basically creates a new field under the root, the unified root type. Let's say you have a MySchema type, source, and it creates a MySchema field, and it creates a new query type, which contains all the query fields. And yeah, these are the solutions we have in Mesh. It's just a matter of preference.
Yeah.
I'm not sure if you're covering that part of the workshop, but in Mesh you can extend and add your own GraphQL, SEL, and your custom resolver. And then basically, if that's what you want to achieve, both to both, Mesh gives you the SDK to write your own code and delegate the code to both. And then you can
Yes, programmatic usage.
So it is possible, but it's also possible to avoid it if you don't want it to happen. Very good.
I leave room for questions afterwards, but let's continue a bit. I want to show you the stuff we did not cover. I mentioned that Mesh has got multiple sources, data sources that you can manage. So here is a list of the things that Mesh knows how to digest. I mean, the list is rather big. It does not really cover every data source, but it does cover like the most popular ones, and knows to manage each and every one of them with its own handler. On top of that, we mentioned, I mean, just to name a few, there is Postgres, MongoDB, SOAP, gRPC. I mean, you see it in front of you. On top of that, we touched one transform that we can do to the schema, but there are plenty. Let's see where the list is. Oh, we've got no list. Here is the list of transforms. We've got a list of rather many type of transformation of changes that you can do to the schema. you can either extend it or federate it. You can filter if you've got, like the first source that we saw, it's got plenty of fields, and we want to filter it out. We can do it. We can do a naming convention. It's relevant to some of the questions that were asked before. We can add a prefix if we want to do it globally. We can do multiple of manipulations to the schema that we generate. That's what you can see here. And the third power of Mesh is adding the plugins to it. You can see the list of plugins we've got. They're either security plugins, multiple types of it. We can rate limit the request based on a variable or a context variable or other variables. And we can do multiple type of caching, depends on the needs of the project. And I think what's interesting on top of all of that is the use cases of it. I mean, we exampled how we create this proxy and merge together, mesh, multiple data sources. But it can be either used as a proxy layer between some external sources that we use and our backend, like from secondary providers, or it can use internally. We have worked with some companies in which it's a known issue. Teams doesn't always have the best communication in between, and some of the backend teams that control those data sources doesn't provide a good schema, or just the communication is not so well. So Mesh is a layer in between that prevents breaking chains and converts it to a spec that the front end, the client developers know how to manage. And another way of implementing it is creating SDK. Mesh knows not to create a runtime proxy, but to create an SDK, which you can use in the code. Either in the proxy that you already got, you can use Mesh as an SDK and implement it in the proxy, or you can even implement it directly in the client itself. I mean, you can use this and use the sources directly into the client using the Mesh SDK.
And then you can also use Mesh as a federation gateway, supergraph. So there are, first, you can basically use it as a drop-in replacement for Apollo gateway. You can basically generate, like if you, let's say, you generate the supergraph STL using Apollo's tool or something like GraphQL Hive, and you can easily consume this pre-built supergraph STL based on by using another handler, which is supergraph handler. You basically provide the URL, and you can give the headers, or it can be a path from the file system. Or let's say you have subgraphs, but one of the source doesn't have it is not a subgraph. For example, it can be also an OpenAPI source. It can be a gRPC source that you want to federate into with other federation subgraphs. So you can just use subgraph transform. You can define the key, some field configuration. You can also define the references over here. As a code file, I mean, you can also do it programmatically or do it declaratively. Yeah, this is also another feature in Mesh we didn't show.
Yeah. Another thing that I think is worth mentioning, I mean, it's related, Uri touched it before, but I'm guessing some of you are asking, is it battle tested? What is the performance of it, and so on? So I think, Arda, you can share. We created a benchmark lately and tried to do a comparison between the available tools which do similar things to Mesh.
So yeah, Dotan will talk about it, but yeah, I won't dive into that much. So here we see, yeah, obviously it is not faster than gateways written in Rust and Go, but I think it is pretty fast. So here you can see the first, I'll go from bottom to top. So the first one is just running mesh in Node in production mode, and it runs on a single CPU core. The performance will probably be better if you have multiple CPU cores or you have more memory. But in here, we have very limited sources. So here it starts with Apollo server, which uses Apollo gateway in JavaScript, and it cannot handle all requests in benchmark, which is not important. But the first one is mesh, and the second one is using bun, which is faster, and the third one is faster because it uses supergraph. And the last one is using supergraph, but it runs on bun instead of node. So yeah, this is the results, and it is, in my opinion, it is pretty comparable with the other implementations. So, excuse me? Oh, so yeah, Bunny is, yeah, it's a question. So we all know about Node.js. So Node.js is a runtime environment for JavaScript for the server side. Bun is an alternative for that, but it uses a few different approaches. For example, it uses Fetch API in the server side. Instead of, for example, in Node, you have Node-specific things to handle the server-side stuff. But in Bun, you don't need to learn environment-specific stuff. You can just, if you know Fetch, you can just write the server-side applications in the same way. Not the same way, but similar way. So Bun is an alternative to Node, I would say, but it is really new. I'm not sure if it's usable in production yet, but this actually shows like how Mesh core implementation is fast enough. I think one thing we should mention is that Mesh can run anywhere in any environment that supports JavaScript. So that's why we have artifacts. I can show this very quickly. So here you can see where you can use Mesh. You can actually deploy Mesh on Vercel as a Next.js API road. You can deploy Mesh as an AWS Lambda on the edge. You can deploy Mesh Cloudflare workers and some other options. You can also use Mesh as an express route with specify and so on. Yeah, I'm finished.
You wanted to say something? Yeah.
Just wanted to expand on the benchmark you just shared.
Yeah.
Thursday, Dan is giving a talk about this benchmark specifically. What we've done is we work with many companies to just compare the different GraphQL layers, probably about the process and other things. So we decided to just open source all the different use cases and like a very deep benchmarks that we've another thing in the conference, and that's a surprise. But for most companies, and when I say most companies, I mean like extreme majority, the results here will be very more than sufficient. Especially with bar, right? So also it's interesting, like we just by doing that, and like Arda mentioned, like we build a lot of toolings around JavaScript so we can run anywhere. That also led us to like be in the center of all the new drama around Bun.
Yeah, that's why we put it here.
All the Twitter files and everything, and many people are like throwing numbers out there, and just because we have real results, I think a lot of people came to us and like we're in the center of the drama. But you can see even without Bun, let's say you're now like putting Bun aside for a second, like you see the results are definitely not like much less than the Rust router or Go-based router.
Yeah, but we also did some tweaks in Node to issue that.
Please note a lot,
Yeah.
like, and also the second most important point here is that whenever you use mesh with Bun, or you use mesh with Node, or you use mesh with Cloudflare workers, your code will stay exactly the same. Like that's the core of the library that just with Arda built. Like, it doesn't require any more from you. Like we've done the role for you.
Do you see also like a lot of performance of using GraphQL versus REST, or using GraphQL with gRPC? Is it like a big difference over there?
Can you repeat the question?
So if there is like a big difference in performance using GraphQL with REST or GraphQL with RPC?
Which sources you recall?
Yeah.
Yeah, so currently all those, like these benchmarks is actually just testing GraphQL gateways, meaning like all the subgraphs here are GraphQL gateways. So we're not testing here if it goes to gRPC or to REST. I'll just mention, and maybe something Arda probably wants to say, is that when Mesh translates a source into GraphQL, it's not just like doing the same execution and does the transformations. Like there's a different handler for each type of those requests in order to maximize the performance for each handler. For example, if you have a query and that query sends like a request to gRPC and then there's a request to REST and some part comes from GraphQL, it won't execute for each resolve. It won't execute again GraphQL translate. It will actually send the REST request in the most common way in the REST mode, and gRPC the same.
Yeah, these benchmarks are actually, yeah, Mesh is here is a super graph gateway. It's not a gateway with REST sources. Actually, yeah, we want to prepare one with REST sources, but if you have any alternatives on your mind that we can compare Mesh with, because yeah, like it's hard to have, I mean, like have benchmarks for Mesh, because Mesh has like many features. Like it depends on like there are a lot of combinations that you want to test in this case. Like it's hard to have a certain benchmark.
Yeah, it's true. Because it's a super tool and it's modular, it depends on which module you use, technically. So
yeah. In this
you
case,
should
this
create
is just
multiple
federation.
cases for multiple combinations, and it will be somewhat different.
Yeah, I guess what they're trying to say is like we're now testing here. This was the test for like let's say compare Mesh to or router or Graph as just a regular browser, like as just a regular gateway. The full abilities of Mesh, like we have nothing to compare to. We have the other stuff, like because the other tools are not able to federate any source, right? It's Mesh.
we kind of drifted into the benchmark stuff, and we'll have a time for it on Thursday. So just to wrap it up, Mesh is our solution for multiple kinds of problems as a super tool, which both creates a gateway or SDK to federate multiple and different type of data sources, transform them, and add multiple functionalities on top of it as plugins. I will just mention, because I didn't mention before, that if, it's a GraphQL conf, but if you really love REST APIs, we have a plugin, Sofa plugin, which then converts the GraphQL schema back into REST API endpoints, and then you get one proxy that merge it all up, do the changes, the transformation, the plugins, and converts it back to REST API. You can also do that with Mesh. Time, it ended a bit shorter than we expected because we didn't have the hands-on experience, unfortunately, but it's time for another round of questions if there are. Yeah.
Yeah, so for example, this combines multiple calls to different services, but then does this integrate with Hive or with any of the other tools? So you can, for example, look at the aggregated data of like your other calls, like P90s or speed times, stuff like that, errors.
Yeah, Dotan is the expert Hive here. Yeah.
The question was if this setup of GraphQL Hive can be integrated with Hive schema registry. So the first
Yeah.
part.
Want to come? Yeah.
The first part is where you convert your sources into GraphQL and then you get a GraphQL schema. You can basically push that into Hive just like a regular GraphQL or schema registry.
Oh, good.
And this basically give you the power of a schema registry for OpenAPIs. Let's say someone from the underlying services changed the OpenAPI spec for one of the services. You can catch that on the GraphQL level because GraphQL Hive will tell you that there is an actual breaking change. A field was removed or renamed or a type was changed because of the result of Mesh changed. So this is the first part. The second part is Hive can be integrated with Mesh for tracing and monitoring. And that means that all the requests that you're running through Mesh are reported to Hive, and you can have this view that shows you the latency, the queries that were executed, the fields that were used, and how that performed in overall. Mesh also has integrations with other tools, tools that are I would say like the experts on how do you do observability for a complex network architecture, let's say. So if you're using Sentry or Datadog, you can use a plugin in your Mesh setup, and then Hive will give you the visibility and the big picture of GraphQL. And Datadog or Sentry or New Relic, doesn't matter, we have plugins for all of them, can give you the big picture of the upstream calls, the HTTP calls, database calls, and then you can have this full understanding of your API.
Just to add to all of that, if you take everything that Dotan just said, that also means that basically thanks to Mesh abilities, like we talked about Mesh as like a gateway, but basically what we started seeing more and more is Mesh gives you the abilities to use GraphQL tools like Hive on APIs that are not GraphQL at all. And that's something that we were surprised to see, but now we actually are working with more and more companies that, let's say they're very early in their GraphQL journey, or they're not even ready for adopting GraphQL, but they want Hive, and they want to prevent breaking changes, and they want to do those things. So they use, in their CI, they use Mesh to convert it into a GraphQL representation, and then Hive to send it to the schema registry. And then you can get these tools, basically, even if you're not using GraphQL at all. Like it gives visibility for the REST API teams that they didn't have before.
Wouldn't it add latency because of all these plugins?
Wait.
Latency?
Because multiple plugins.
Not that much. I would say it depends on what it is.
wouldn't it add latency for adding these plugins? Like already the mesh, the response time average is 8.5 seconds. Okay. Wouldn't it add more latency by converting this, having these plugins over and then getting responses? And I see that average on mesh is about 8 seconds or something in the previous slide, and Apollo router is 2.5. And we use GraphQL Federation, and one of the biggest problem was latency on the stitching. And then we changed to router. It is faster, but still it's no compared to regular stitching of manual stitching of other graphs. So how does this help in the productionalized, like large scale companies?
Yeah.
Where performance is important?
It is a good question. I'll break the answer into multiple parts. First of all, it's a good question where the latency comes from. And when we deal with a proxy, you don't control all of the latency variables. As for multiple plugins, it depends, again, on the combination, because some of them add complexity and will add some latency and some not. And when you're talking about benchmark, again, it's a question of what you want to measure. That's one of the reasons we did our benchmarks open source, because then it's open to review, to criticism, and to improvement.
Yeah, I'll add two things to that. First of all, about the point that I had, it has nothing to do with latency because it's a developer. When you use Mesh on CI and Hive, that's a development process. It's not actually affecting the root at all. So you can use whatever router, so then the latency doesn't matter at all. But I would love to hear actually about like your benchmarks of doing and your latency, because again, if you look deeper into that benchmark, like Hive, what we've done, there's a couple of different, again, there's a whole talk that Otan will give about it, but there's 3 different scenarios where we test everything, including latency and including like how you ramp up usage and like memory and everything. Like if you click and you just, Arda, you can show like everything we measure. I would love to see how we should compare, because I think Mesh is extremely low latency at this point because of kind of all kinds of stuff that we've done recently. And yeah, we should definitely compare the results and see your benchmarks and ours. I don't think Mesh is like, has much more latency than the Rust router at all, to be honest.
Dotan will talk about it, but you can see all the parameters we calculate here. But this is a specific scenario. I don't want to like give spoiler that much, but yeah.
Any questions? All right. So thank you all for participating. I will say that we didn't have much chance to do hands-on, but I do encourage you to just go and wander around in the Mesh website, because it's a very, it's got variety of plugins, transforms, whatsoever. See if anything catches your eyes. If you have any further questions, we're here during the conference. Feel free to ask us about anything related to Mesh, related to other guild stuff, or just say hello and introduce yourself. Thank you for participating.